Mount Cleveland is one of the most active volcanoes in Alaska. When I was passing by with a ship, it was not erupting, but there were quite some gas emissions going on in the summit crater. Mount Cleveland has a steep slope and forms an almost perfect cone. This is the typical geometry of a so-called stratovolcano or composite volcano. Carley's Island, located right next to Mount Cleveland, is also a stratovolcano, but it's much less active than Mount Cleveland. When stratovolcanoes erupt, their eruptions can be both explosive and effusive. During explosive eruptions, lava gets fragmented and can form ash clouds. Ash and larger fragments are deposited around the volcanic vent. The fragmented pieces of lava that are ejected during explosive eruptions are called pyroclasts. The largest pyroclasts are bombs and blocks. We can see in this shot from La Palma how a large bomb is ejected from the vent. Smaller pebble-sized pyroclasts are called lapilli, and the smallest ones are volcanic ash. Over time, the pyroclasts can build up a steep volcanic cone. During effusive eruptions, very viscous lava is emitted. This lava forms so-called block lava flows or lava domes. Block lava flows are thick, short lava flows. Lava domes are dome-shaped structures that form when viscous lava piles up around the volcanic vent without flowing away from the vent. Therefore, no elongated structure forms that could be called a flow. Both lava domes and block lava flows are very thick. This shot is from Big Glass Mountain in California. The block lava flow here is about 75 meters in thickness and about 1000 years old. And here a lava dome from Long Valley Caldera in California. If several of these block lava flows and lava domes are erupted one after another, the thick and short domes and flows will form a steep volcanic edifice. Together with the pyroclastic material from explosive eruptions, this creates the typical steep cone shape of stratovolcanoes. Eruptions at stratovolcanoes can often begin with strong explosive activity and then end with a fusion of block lava flows or lava domes. This is because the gas-rich magma that is responsible for explosions accumulates at the top of the magma chamber and erupts first. After that, less gas-rich magma can erupt effusively and form a lava dome or block lava flow towards the end of the eruption. Because of their explosive nature, stratovolcanoes can be very dangerous. Ash clouds can suddenly collapse and form incandescent avalanches up to 800 degrees hot and several hundred kilometers per hour fast. Such pyroclastic density currents or pyroclastic flows incinerate everything in their way and can lead to great damage and great loss of human life because of their speed and their unpredictability. A famous example of a pyroclastic flow is the flow that covered the ancient Roman city of Pompeii in the year 79 when Mount Vesuvius erupted. Interestingly, stratovolcanoes often start their life as shield volcanoes. As a shield volcano evolves, its magma composition can undergo changes leading to more explosive eruptions and the effusion of more viscous lava flows. Therefore, some stratovolcanoes have an old base that is a shield volcano on top of which the stratovolcano started to form. Mount Etna, for example, has a gently sloped base to up to about 2000 meters above sea level. On top of that, the volcanic edifice becomes steeper and more like a stratovolcano. At the moment, Mount Etna's eruptions have characteristics of both shield and stratovolcanoes. It is somewhere in between those two volcano types. Have you ever been on a stratovolcano? Let me know in the comments.